Alright folks, welcome back to the channel. Today, we're diving deep into a head-to-head showdown. The KM178F diesel engine versus a 13 horsepower gas engine. We're going to put them to the test, focusing on their RPM, or revolutions per minute performance. This is crucial because RPM directly impacts power, output and overall efficiency. First up, let's introduce our contenders. The KM178F is a single-cylinder, air-cooled diesel engine, often found in smaller agricultural equipment and generators. Diesel engines are known for their robust design and fuel efficiency. On the other side, we have a 13 horsepower gas engine, a common sight in lawn mowers, go-karts, and other recreational vehicles. Gas engines are typically lighter and offer quicker acceleration compared to diesels, but they often come with a trade-off of lower fuel economy. Now, let's talk about RPM. It's the lifeblood of an engine, representing how many times the crankshaft rotates in 1 minute. Higher RPM generally means more power, but it also increases wear and tear. Lower RPM often translates to better fuel efficiency and longer engine life. We'll be looking at the RPM range of both engines, from idle to maximum operating speed, and how they perform under different loads. We'll start with the idle RPM. This is the engine speed when it's not under any load, just ticking over. The KM178F diesel typically idles around 800 to 1000 RPM. Gas engines, like our 13 horsepower, tend to idle a bit higher, often around 1200 to 1500 RPM. This difference is partly due to the combustion characteristics of each fuel type. Diesel engines require a higher compression ratio, and thus a slightly slower idle speed. Next, we'll examine the RPM under load. This is where things get interesting. We'll simulate different workloads to see how the engines respond. The diesel engine, with its higher torque, should maintain its RPM more steadily under load. Gas engines might experience a drop in RPM as the load increases. Unless they have a sophisticated governor system, we will compare the RPM drop of each engine during the simulated load test. We will also look at the peak RPM. The KM178F diesel usually tops out around 3000 to 3600 RPM. The 13 horsepower gas engine can reach a higher peak, often in the 3600 to 4000 RPM range. This is because gasoline burns much faster than diesel fuel, allowing for a higher redline. However, it is important to remember that running an engine at its peak RPM constantly can be damaging over time. It is therefore important to operate the engine in its most efficient range. Finally, we'll consider fuel consumption. The diesel engine, known for its superior fuel efficiency, will likely use less fuel per hour at the same RPM as the gas engine. This is because diesel fuel contains more energy per gallon, and diesel engines are generally more efficient at converting fuel to power. The gas engine, with its higher RPM and less efficient combustion, will likely consume more fuel. So, who wins? It depends on your application. If you need raw power and fuel efficiency, the KM178F diesel engine might be the better choice if you prioritize lighter weight and quicker acceleration. The 13 horsepower gas engine could be more suitable. Ultimately, the best engine depends on your specific needs. Thanks for tuning in. Don't forget to like and subscribe for more engine comparisons.